In neither class did we get to the question of what is the probability that you have a disease given a positive result on a test. So let's do that here quickly so that you can do the problem set. It's also done in the reading if you don't like my way of looking at it, so you can check there as well. First, we have to define false positives and false negatives because that's where I got things confused in the first class. The true positive rate is the chance that you have a positive result given that you have a disease, and the true negative rate is the chance that you have a negative result given that you're healthy. The false positive rate is the chance that you get a positive result given that you're healthy, and the false negative rate is the chance that you get a negative result given that you're diseased. With COVID-19, most tests have a much higher false negative rate than a false positive rate, which is nice because we don't want to have a lot of people and all their contacts undergoing quarantine based upon a mistake. Let's take the false negative rate to be maybe 15% and the false positive rate to be only about 1%. That means 15% of sick people will be told they're okay, but only 1% of healthy people will be told that they're sick. But now let's ask the question, what is the chance that you are actually sick given that you got a positive result? You might think it's 1%, but let's check into that. One other thing we're going to need to know here is the prevalence of the disease in the population. It turns out that that becomes a very important factor in our calculations. Let's assume, just for the sake of argument, that the disease is currently affecting 2% of the population, and we'll use that for the probability of disease. So here, what we're looking for is the probability of disease given a positive test. But what we have access to is the probability of a positive test given disease. And so we think to ourselves, here's a place we can use Bayes' theorem. So we can write that the probability of disease given a positive test is equal to the probability of a positive test given disease times the probability of disease, all divided by the probability of a positive test. Well, probability of a positive test given disease is the true positivity rate, which is 85%, and the probability of a disease is 2%. The probability of a positive test is a bit more complicated, but not so much. There are two ways to get a positive test. You can have the disease and get a true positive, or you can not have the disease and get a false positive. The numerator for this equation gives us the fraction of tests that result in a true positive, so that's the first term. And then the false positive fraction is just the fraction of healthy people who get a false positive test, which is 1%, times the fraction of people who are actually healthy, which is 98%. So now we just do out the math. 0.85 times 0.02 is 0.017. So that's the top, and then we add that again, plus the 0.01 times 0.98, which is 0.0098. We just pull out our calculator, figure out what that is, and we come up with 63% of the people who get a positive test actually have a disease, or about 63%. And that's the answer.